This is the first video for the lectures in introductory statistics, or intro stats. I'm Josh Eggenberger, and we're going to be using the text from openstacks.org. You can find it by going to the site. From the subjects menu, choose math, and then introductory statistics. The same as the name of the course is the name of the textbook. And it should be a yellow tile if you're looking for that. We're going to start today with chapter 1. And if you can write down what I write down on the board, you're going to have really good notes for the course. Chapter 1, though, is a little bit different in that we're going to have mostly terminology and definitions and concepts. Later on, we'll get into more mathematical tools, but chapter 1 is called Sampling and Data. So the sections are decimals, and section 1.1, the first section of chapter 1, is statistics, probability, and key terms. So as I said, the definition or terminology that we're going to use to describe data is kind of the main object of statistics. And sampling is how we collect data. We'll go into a little more detail of that later. But statistics itself is, I have a pretty concise definition as far as being complete as well. It's got kind of 4 main procedures and activities that we do in statistics. So I think this is a good description. The science of statistics deals with and here's the 4 things, the collection, analysis, interpretation, and presentation. Of data. So this really isn't that good of a definition because first of all, I've got 2 things underlined. I'm kind of defining them both. We can't really discuss statistics without mentioning data because that's the primary object of statistics. But there are these 4 things that we do with data that are the activities of statistics. Collecting it, and that's the sampling process. Building a data set. Analysis, well, counting and measuring, and we'll get into analysis later. Analyzing, we're going to analyze. Interpretation, what does it mean? What does the data mean about the sample and the greater population that we get it from? And then finally, presentation, presenting, describing, or making a picture, displaying the data. We can use graphs, and we'll get into that. So to start with, this is kind of what we're going to be doing. We're not really going to do collection of data. We're going to focus mostly on analysis and interpretation. But presentation also can help us to interpret, to see the meaning of data. I've got an example of a data set. And it comes from a sample. We don't have to worry about the process of sampling in this one. We just have the data. So example, and I'm not going to write that word anymore. I'm just going to write X for example. We're going to do a lot of examples. This one is the average time spent sleeping per night in hours. So I want to mention that, but that's really not the focus of this sentence. That's just a detail. The average time spent sleeping per night for 14 people. And I know that's not really a sentence, but that's what we're going to be examining here. That's what the data are going to mean. It's the average number of hours per night. So it doesn't say whether it's averaged over a week or a month or a year. This is just all we have, average nightly hours of sleep. And the data are, so in this case, the data are a list of 14 numbers, one average number of hours for each of the 14 people. So 14 numbers, that's kind of a lot of numbers. I'm gonna write a row with 7 and another row with 7. It'll be a little bit easier to read. 5, 5.5, 6, 6, another 6, a 6.5, and another 6.5. Sorry about the scrunch at the end there, but the 1, 2, 3, 4, 5, 6, 7, and then another 6.5 and another 6.5. A 7, another 7, an 8, another 8, and a 9. Okay, I didn't line up the numbers like I wanted to, but there's 7 in this row and there's 7 in this row. There's 14 numbers. So somebody had an average of 5 hours per sleep, 5 hours of sleep per night. Somebody had an average of 5.5. 3 people had an average of 6 hours of sleep, and so on through the whole list of numbers. This person had an average of 9 hours per night, which is quite a lot. So what I want to do with this is show you a way of presenting it that makes it easier to understand what the data set is like. And this is called a dot plot. You'll be able to practice this in your homework a little bit. So notice that the data the data range from a value of 5 at the smallest and value of 9 at the largest. So what I'm going to do for my dot plot, is draw a number line with 5 at the low end, and then 6, 7, 8, 9, 6, 7, 8. So that's really the breadth or the spread of my data. And for each of these, 5, there's only one 5. And there's only one 5.5, so 5.5 halfway between 5 and 6. There are 3 values of 6, so I'm going to put 1, 2, 3. See how I'm stacking those? Because they're all at the value 6, but now I've got all 3 of them in the same place. There are 4 values of 6.5, so halfway between 6 and 7, I'm going to put 4 dots, 2 7s, no 7.5, 2 8s, and 1 9. And that is a dot plot. It's a way to display graphically or visually the data set. And I think this is easier, like the typical number, the average number is right around 6 or 7. And you can see that from this. From this list of numbers, it's not quite as easy. Although this data is organized. I wrote it in increasing order. And that's one of the first things that you would want to do with the data set is put it in order so you can, we'll see the different things that we're going to do with data when it's in order. The other thing I wanted to mention about this is that the average is 6.68. Hours, approximately. And that is a statistic. That's the kind of thing that we're studying. A little more on that later, but the average of all these numbers, 6.68, is what I get when I add all the numbers together and divide by 14. So the sum of the numbers divided by 14 is the average, and I rounded it to do two decimal places. Another thing to notice, though, is that these are all either whole numbers or halves, halfway between two whole numbers. And this is neither of those things. So this is a different kind of number from these in a way. But where it came from, in a way, it represents all this data. Now, it doesn't contain all the information of all the data, because there's a lot of data sets that have this same average. It's just for this data set, this tells us one number that summarizes. And we'll see others like it. So that's the ordinary average. Back to some of the terminology that we're going to use. And like I said, this lecture is a lot of definitions. If you write them in your notes, your notebook notes, you'll have an easy reference. And I hope that by the end of the semester, your notes, your notebook that you write will be better than the textbook itself. The textbook is pretty good, but it has a lot in there, and it would take a very, very long time and a lot of effort to read it all. But if you understood most of it, that's essentially the same thing. And if you have the essential pieces of information in your notes, that'll be a guide for it. So kind of picking back up, organizing and summarizing data, which is just what we just did. We organized it into a graph, and then I did a little summarizing with when I wrote the average down. But organizing and summarizing data is descriptive statistics. So descriptive statistics, you can see that in the root of this word, we're going to describe the data, which is the first step. Drawing conclusions from data, using probability. Is inferential statistics. And you can see in the root of that word, infer. To infer it's kind of like to assume, which is kind of a guess as to what things are going to be. But inferential statistics is an informed guess, which is different from a random guess. So this is the tool. Probability is the tool that lets us do this, and it's probability is the mathematical study of randomness. So the mathematical study of randomness is what we call probability. And it's a slippery thing to study. So it's random. That means there's no patterns in it. Random, messy or unformed, unrecognizable organization. But mathematics is the study of patterns. So looking for patterns and randomness, not always, but typically what you find is that something that looks random actually does have patterns and underlying laws governing whatever the behavior is. It can look like randomness, but when we study it mathematically using probability, we can make sense out of this, and we can even use that to draw conclusions from data that are not just guesses, but informed and even more than that, quantified guesses. All right. So those are the two main branches of statistics. This one is fundamentally linked with the idea of probability. Back to the word in the title of the chapter, I think. Yeah, sampling. It is the process of selecting a sample. So, pretty closely related words, which is used to study a population. And that's another key term there. Population is the everybody. Sometimes we're going to want to think of our population as being the population of all the people in the world. So we could take a sample, for example, our statistics class, 20, 30 people. That could be our sample to represent the whole population of people. That probably wouldn't be a very good sample to represent the population of Earth. But actually our sample might be good as if our population was all the students at SLCC, then the population of the people in our class could be the sample to represent that. And that wouldn't be too bad of a sample, but there's a better kind of sample. Whatever the population is, if you choose the sample randomly, that turns out to be, on average, the best representation of the population, a random sample. We'll look in a little bit more detail at the sampling process and randomness applied to samples. So I've got a few more terms that kind of go together. So I'm going to start from the clean board and this one. So not statistics. I mentioned earlier that statistics is the mathematical study of data. A statistic is related. It's not the same thing, though. A statistic is a number that represents a property of a sample. For example, the sample that we saw of the sleep times, the number of hours of sleep that people get on average, if that was a sample of 14 people, kind of was, the average was a number that represents a property of the sample. That average that we saw is an example of a statistic. There are other statistics too. The definition that goes with this one, parameter, is a number that represents a property of a population. Let's call those sentences. So a property of population, for example, the average number of sleep hours people get worldwide, that average number for that population would be a parameter. Whereas when we looked at a sample, we got a statistic, but it corresponds to the same type of number. It's an average. It's just that if it describes the population, we call it a parameter. And if it describes a sample, if the information comes from a sample, we call it a statistic. They're not different usually, but what makes, I guess this is just kind of a lucky chance that this occurred, although it might be just because these words are like this, that they are in common use. But the letter S at the beginning of statistic and at the beginning of sample, and the letter P at the beginning of parameter and P at the beginning of population, those are just marks for emphasis. Statistics are properties of samples, parameters are properties of populations. So that does make it kind of nice to keep track of them. Also, I'm not going to write that word anymore. We can use the abbreviation POP for population. The rest of these really aren't going to come up very much. Well, the word stat comes up, I guess, but stats is the subject that we're studying, stats. Stat means now. Anyway, all right, I want to erase these two so we can look at the next group of terms, and they're basically related to this concept that you studied in algebra, wherever you studied algebra, x equals, yeah. The variable, sometimes the x and y variable, and there is a one unit in this course where we're going to study two variable situations, but almost all the time we'll be studying single variable. Variable is a characteristic of each individual in the population. And the main property of this, the most important thing about it, is that it varies. V-A-R-Y is the root here. Vary, and to vary means to change from individual to individual. So if we talk about individuals' heights, everyone in the every human in the world has a height. We would probably do that in centimeters because most of the world uses centimeters to measure height. But everyone in the population has a height. Now, if we got a sample, we would only measure the people in the sample. So even though we're not measuring the whole population, the individuals in the population have a height. We just don't know what it is. We only would have data from our sample. But variable changes, and it's going to be a characteristic of each individual. Now, there are two types. Numerical variable, a number, that describes an individual. So, numerical number, it's a number. But contrast that with a categorical variable. And a categorical variable places each individual into a category. Another way to say that is a type. For example, I mentioned earlier measuring heights of people. That would be a numerical variable. Every individual has a certain number of centimeters that they are tall. A categorical variable would be like what kind of, what manufacturer of car do people have? So the categories would be things like Toyota, Ford, Mercedes, none. A lot of people don't own a car, so that's a category. But the type of car doesn't really have a natural way to describe it as a number. They're just categories. And we could have the first, second, third, fourth, fifth categories, but even if it's alphabetical, that's still arbitrary as far as the meaning of those numbers. Okay, and then to finish up this section, I have some terms that kind of get to the details of data, the values of the variable. So a variable measured across each individual in a sample gives us a bunch of different values. We measure everyone's height, we get a bunch of different values. If we take a poll and ask people what type of car they have, those would be the values, even though they're not numbers. But that collection of values is the data, datum. So this word is data or data. Both pronunciations are fine. Datum is a single data element. And let me say a single value of the variable. So just one value of that variable. Here's the thing though. A datum is not worth as much as data. Because we're looking for patterns in data, and if there's only one value, there's no variability to it. There's no pattern that we're going to find. That's just one piece of information. Data is more than the sum of the parts. It gives us an opportunity to study the pattern in the numbers, in the way the numbers tell us things, rather than just the context. Two more things. The mean is, I've already mentioned it a little bit, but we call it the average. And it's technically what we call the average is the mean, or the arithmetic mean or arithmetic mean, or the ordinary average. Add the numbers, divide by the number of numbers. And we'll do that quite a bit, but that's the name for it. There are other types of averages. In this chapter, we're going to look at the median and the mode, which are other ways of seeing what the typical element is like, or what the typical data value is like. They are averages. They're just a little bit different from the mean. And then finally, proportion is, it's like percentage. It's the fraction of the whole. So the proportion of people that get more than 6 hours a night, for example, that's most people, according to that data earlier. Anyway, proportion, it's like percentage. So the example I want to do is something simple. 30% is the percentage, but as a proportion, the fraction of the whole is 30%. I'm going to write that out as words, but also space out the parts of the word per cent means 100. This 30% is 30 per 100, or 0.30, 0.3 even. You don't really need that extra zero. It just, if you write it as 0.30, you can see that the 30%, 30 hundredths, is the same digit. So if I have like 35%, that'd be 0.35. But that's the proportion I'm talking about. Or as a fraction, this fraction could be reduced, but it doesn't matter. It's not 30. 30% is not 30. 30% is 0.3.